All right, team, let's talk standard any, right? What is standard any? Standard any is basically a type safe object. It can hold any value, and by any value I mean value of any type. Can be primitive, can be a user defined, right? It can only hold one single value in it, and it's basically a class that's part of the standard library, has a constructor on it, has a destructor, has an equal to operator, and a bunch of functions. Now you might wonder, okay, what's the use case, Dev? What's the use case for this standard any? So let's start by imagining some program, right? Let's imagine we have a function, and let's call this function add, right? Add will be called by some client code, right? And this add can take in any type of value, right? So let's say it takes in a value of that can be of any type, and it also takes in, let's say, a vector, right? Vector, and let's call it container. The goal of this add function is to simply add this value to this container. That's it, right? The problem is you don't know what the type of the value will be, right? It can be an int, it can be a double, can be a string, can be a char, can be a user defined type. You don't know, right? And this is where standard any helps, right? So you can make this vector of type standard any, right? And let's make this function a templated function. So let's say template type name t, and like we said, right, it doesn't do much. It's a void type function, and all it does is simply add to this container. So we'll do container dot pushback value, right? So some client code out there is will call this add, and you don't know what the type of the value will be, right? And this is where standard any really helps. So let's actually make use of this function here that we built, right? Let's add a bunch of values to our container. So let's start by declaring a container here, and let's say we are going to call it generic container. It can hold a value of type standard any, right? And let's start adding a bunch of values to this container, right? So let's first add maybe a int, right? So let's add a int. Let's do a float. Let's say 9.9 f. Let's maybe add a double, so we can do something like, I don't know, 69.69. Let's add a string maybe, right? Let's add the channel name. Let's add a char, and let's also add like a user defined type, right? So let's quickly define a struct here. Let's call it person. Let's give that person age and a name. Why not? And let's add the person as well, right? So person 31, let's say his age is, and let's say his name is Nin, right? And let's at the end, let's print the size of this container, right? So we can do something like this, right? Dot size. So hopefully if our code is right, we have now created this generic container with 6 objects, right, of different types. You literally have almost every type of object in this container, right? So let's run this. There you go. The size is 6. Like I said earlier, right, the standard any class exposes a bunch of functions, right? And the two important ones are you can check if this object has any value in it. Like you can initialize a standard any with an empty value, right? You cannot give it any value and it will still be fine, right? It's just a standard any of an empty value. But you have a function called has value that checks if the object has any value in it, and you can also check the type, right? So let's add some more code to see what we get if we check those two attributes, right? So let's use a const auto ref, let's say a on the, let's go over the generic container and let's do uh, a dot has value. This will tell us if our object has any value in it, and let's also print the type of that object, right, of the any object. So let's do a dot type. I think a dot type returns a type ID, and then if you call name on it, you should see the type of the object, right? So let's add an endl here, and let's see what happens if we run this program. Right, there you go. Let me zoom in a bit. So size is 6, right? Has value is all ones, which means yes, all the objects in this container have some kind of value in it. So has value has returned a true for all the 6 objects, and you can see that it also has indicated some information about the type of the object in the container, right? So we got an I for an int, F for float, we got a D for the double. For string, I think this stands for pointer to a const char. I think that's how strings are represented, right? You have a C here for a character, and you have the person object, right? All right, guys. Hopefully the use case for standard any is much more clear now. Uh, Before standard any was invented, I think in C++17, you could have solved this problem of having a container of generic types in various different ways, right? And one of the ways you could have used is you could have had like a common interface, and you could make all your objects inherit from that interface, and then that way you can have a vector of like the base class base interface pointer type, right? So standard any definitely helps making your code much more easier, and if you need to store values of different types in the same container, you can make use of it, right? So I want to conclude the video here. Hopefully you got some idea of what standard any is and when to use it, and feel free to play around with it. And as always, if you like the video, please leave a like, hit the like button, and if you have any comments or questions for me, please leave in the comment section.